Okay, hi. So we're struggling with multi-step problems. Sometimes the multi-step problems are going to be explicitly said, hey, this is a multi-step problem, and other times they're not, and you're going to have to read the question and figure out this thing has multiple steps. To me, this is the most useful thing about physics, is learning how to break down complicated problems into bits you know how to solve. If you can find a problem that's super complicated, and you can break the super complicated problem into bits that you know how to solve, then you can learn how to solve any problem, and that's part of why this course is super useful. But let's jump in. So Katie's in a car that has a flat tire. It takes her and her 3 friends to push the car. Push is probably going to be force. Okay, the 4 of them do 2,000 joules of work to push the car 10 meters. Oh wow. Okay, now I'm lost because I thought I was thinking about force. Find the force they need to push it using one of the equations. Next, we know that the mass is 1,000 kilograms. What's the car's acceleration? Okay, now I'm overwhelmed. I don't have any equations that incorporate joules of energy, distance in meters, force, and acceleration all at the same time. That's too many things. So I've told you up here that it is a multi-step problem, and we're going to need to use Tetris a whole bunch of different times. So the analogy that I like to use is, first, what's the end game? What's the final thing that we need? It's either going to be what's the acceleration or find the force. So I'm going to look for equations that have acceleration and force, and I'm going to scroll through those equations in my mind or on my equation sheet to find the right one. Now, I've given you a hint here, and I've told you first do this part, then next do the next part. So the end of this is going to be looking for acceleration. The way to do this problem is to draw a little line down here. This is the most important line you'll ever draw. It's the line that you draw to break a complicated problem into pieces that you know how to manage. So this side, we're going to look for acceleration, A equals what? And then this side, we're going to look for force, F equals what? And once we've broken the problem into 2 pieces, effectively, we can forget completely about one side and try to solve the other side. Now, sometimes one side is going to be easier to solve than the others, and sometimes you have to do one side and then the other. So we might have to start over here, or we might have to start over here. I've told you, because I wanted to help you out, that we have to start with the force one because we gave you this word next, this little hint. So we're going to completely forget about this whole thing on the right, and we're just going to focus on the thing on the left, and then, oh my goodness, it turns into all these other problems up here that we've already solved. And we just go through the same process that we've already done, and we go through it just as we had done before, as if this thing on the right doesn't exist. So we need to find force. We're forgetting about everything else, and we see that we have, let's do this first part in blue, we have joules of work and a distance. So, and we're looking for force. So we're going to scroll up and we're going to find an equation that relates distance and force and joules. Now, at first glance, I do not see any of those because I don't see energy in this one or in this one or in this one. I know that energy is here, but this one doesn't have any force in it. I know that energy is here, but it also doesn't have any force in it. This one has force and this funky thing that's not energy. It has no units. By process of elimination, I'm left with this, but also I could have remembered if I remembered that work, the unit of work is joules. And if I would remember that, then I would know right away which one to do. So either by process of elimination or by memory, I'm going to remember that I have to write down W equals FD. Groovy. I don't know F, that's what I'm looking for, and I know D and I know work. So I'm going to plug in my values. The first value I'm going to plug in is my 2,000 joules of work. I don't know F, so I'm going to leave it there, and then I'm going to write down my 10 meters. Now, just for simplicity, I'm going to get rid of these units so that we're solving for F here. This is what we want to find. We talked about this before, the middle school way versus the high school way. The middle school way is to just guess and check. I can see with my eyes that if I put 200 here and multiplied it by 10, I would get 2,000. And so I know that my answer's got to be 200. The high school way to do it is to divide both sides by 10. And then I see that 2,000 divided by 10 is equal to F, because these 10s cancel. And then I see that F has to be equal to 200 newtons because the units of force are newtons. So either way is fine. Whichever way you want to work it is just fine. Then, now that I've done this, now that I've solved for my initial question, which was how do I find force, I've gone ahead and done that. Now I can take this result and plug it in over here. Now, if I cross this line, and honestly, even instead of crossing this line, I can think of, okay, I've solved this, and now I can completely forget about it. Oh my goodness, it's like I didn't even do any of this work. All I need to do, except I didn't even do any of this work. And all I have now is to find an acceleration using a force, and we know the mass, which I've just covered up. So, forgetting completely about everything that's happened over here, even though obviously, of course, it matters, we're just going to pretend that it doesn't matter right now. We have our result from here, we have our mass, and we have a mass and a force. I'm looking for an acceleration. Now I scroll through my equations. I've already used this one, so it's probably not going to be that one again. Could be, but probably not. All three of these equations relate mass and force and acceleration. So I got to pick one. I'm going to pick the one that has me find the thing I'm looking for, which is acceleration. So I'll pick the acceleration equation and I'm going to copy it down. And when I'm doing this, A equals F divided by M. I'm plugging and chugging my F from before, 200 newtons that I calculated, and my M, which is 1,000 kilograms. I could break out my calculator if I wanted to, but I could also remember that just dividing by a 10 or 100 or 1,000 just moves the decimal place. So I have to move the decimal place once, twice, 3 times, and then I will find 0.2 meters per second squared. Again, I know that that's the unit of acceleration, but if I didn't know that, I could scroll up and I could find it in a different spot, or I could have it memorized, or I could rederive it, but we're just going to not worry about rederiving it. So when solving a multi-step problem, it's important to break the problem into bits and solve the manageable bits. That's how you're going to proceed, and that's what's going to help you solve these complicated problems. And once you've broken it into bits, you go through the same process of Tetrising with the equations. Which equations can I use given the information that I have? And more broadly speaking, that's a large piece of what problem solving is about. How can I use the information that I have to find the information that I need? And once you build that skill, it's going to serve you in any class other than, and many classes beyond physics. Cool. Good luck with your homework. I'm still waiting on it from some of you, and I will see you in class.